In this video, we're going to find probabilities for normal distributions. Notice these are not from 5.2. Notice these are not standard normal distributions anymore. We don't have a mean of 0 and a standard deviation of 1. So we're going to have to use our formula for z to convert our x value to a z value so that we can use our z table. So we want the probability of x being less than 78. I'm going to have to say z is equal to x minus mu over sigma and say that x is 78 and mu is 81 and sigma is 5. So 78 minus 81 is a -3. And then divided by 5, that's a -0.60. So the probability that z is less than -0.60 is going to be the same answer as this. -0.60 is 0.2743. I show you that we can get the same thing with our calculator, even though this wasn't a technology problem here. We're going to come in here to second distribution, normal CDF, and we can have a lower limit of -infinity, so -1 second EE 99, and the upper limit this time of x is 78. Our mean is given to us as 81, and our standard deviation is given to us as 5. It's paste and 0.2743. And that's exact to 4 decimal places. So you can do greater than, less than, and between with the calculator. So we'll check all of these with the calculator and show you when the calculator is exactly the same as the z table and when it's off a little bit. 35 is my x value, and I want to be greater than that. So z equals 35 minus 50 divided by 7. It's going to be -15 over 7. Let's pull up the calculator here so I can round this to 2 decimal places. -15 divided by 7. And I'm going to have to say that this is about -2.14. And so I want probability of z greater than -2.14 is going to be 1 minus the probability that z is less than or equal to -2.14. So let's find -2.14. 2.101234. It's right there. 0.0162. And so this is 0.9838. Okay, let's do this on the calculator and see what we get. Second distribution, normal CDF. So now we have a lower bound of 35 and an upper bound of +infinity, which I'm going to represent with second EE 99. Mean is 50, standard deviation is 7. I almost certainly am going to get a more precise answer from the calculator here because I rounded my z value. So 0.9839. See that? We're off by 1 in the 4th decimal place there. So the calculator's answer is the more precise answer, but this is how we have to get it with the z table because the z table only goes to 2 decimal points unless we wanted to look at that z value there. Yeah, we would be going to the closer one that's at the bottom because that's a 2. So there was a little more area there than we supposed. Anyways, let's keep going here. Just wanted to show you that's one example there when we have to round those z values of where we are going to get some difference between the calculator and the z table. 60, let's say 64 minus 81 over 5 is 64 minus 81 is negative 17 divided by 5 is negative 3.4. And 72 minus 81, that divided by 5 is going to be negative 1.8. So probability of being between negative 3.4 and negative 1.8 here is the probability z less than negative 1.8 minus the probability of z less than negative 3.4. Let's pull up our table here. Negative 1.80 is 0.0359. And negative 3.40 is 0.0003. So this is 0.0356. Let's see how we did. So second distribution, normal CDF, lower bound of 64, upper bound of 72, mean of 81, and standard deviation of 5, and 0.0356 is exactly what I got there, just like we expected. I believe that's it for this video. Yes, it is. So we'll come back next time and talk a little bit more about 5.2. See you for the next video.